And so we reach the last of our collection of Chapter 1 Algebra 2 videos. This one is on absolute value inequalities. Now, in a previous video we've talked about absolute value, and a previous video we've talked about inequalities. So what do we do when we have something like the absolute value of x is less than 5? How do we solve that? Now, the way I've conceptualized this is that in this case, the inequality is pointing towards 0. It's less than 5. So on the number line, 5 is here. It's pointing toward 0. So in that case, let me just skip to the end. When that's the case, if the absolute value of a, look at the bottom, if the absolute value of a is less than b, then the answer to this is going to be in between negative b and b. A is going to be in between negative b and b. That's, if you can memorize that, great. If you can't, let me show you how it makes sense. So, if the absolute value of x is less than 5, there can be the simple case where x is already positive. And if x is already positive, that's easy. X is less than 5. But, of course, absolute value fries everything and makes it positive. And so it could be the case that a negative number is less than 5. How are we going to solve this? Well, first of all, I can get rid of that negative in front of the x and put it in a x something form by flipping the sign. This is something from the absolute value video. When you multiply by negative 1, say, multiply by a negative number, the sign flips. So if I multiply negative x by negative 1, a negative times a negative is a positive. That gets rid of the negative in front of the x. And that negative 1 times 5 is negative 5. So I end up with x is greater than negative 5 because the sign flips. When you multiply by a negative, the sign flips. And so here I have my answer. I have either x is less than 5, that's the right hand of this compound inequality, but x is also greater than negative 5, as you see in that one right, the line right above the answer here. The greater than sign is pointing toward the x. And so we put it all together, and we have x is less than 5, but x is greater than negative 5. And again, this is exactly what we predicted we would find. If the absolute value is less than b, then the answer is going to be in between negative b and b. And that makes perfect sense when the inequality is pointing toward 0. What happens when the inequality is pointing away from 0? Well, if the absolute value is greater than b, then we have not the part in the middle. So when it's pointing towards 0, it's in the middle. When it's pointing away from 0, then it's going to be on the outskirts of the number line. It's going to be pointing toward positive infinity, and it's going to be pointing toward negative infinity. So if the absolute value of a is greater than b, then the answer is going to be a is greater than b, or a is less than negative b. Let me give you an example. So the absolute value of 3x plus 4 is greater than 10. Well, there's, in the first case, the possibility that 3x plus 4 ends up being positive. And if that's the case, then it's very simple. 3x plus 4 is greater than 10. Works fine. I can do a little algebra and solve that. So I'm going to subtract 4 from both sides. So 3x is greater than 6. Divide both sides by 3. X is greater than 2. Ta-da! That's easy. Slightly more difficult is this: what happens if 3x plus 4 turns out to be negative? Then the absolute value, is going to fry it and make it positive. And so that basically is going to end up being 3x plus 4 is less than negative 10. I've already done kind of the magic I did in the previous slide, multiplying everything by negative 1, flipping the sign, And when I solve for this one, I end up with x is less than negative 14 thirds, which is something like, let's see, 4 and 2/3, is that right? Negative 4 and 2/3. So if I were to graph this on a number line, basically I would have everything greater than 2 on the one side, or I guess the way you're looking at me, everything greater than 2 and everything less than negative 14 thirds. So that's how solving absolute value inequalities works.